They are fascinating creatures. Everyone knows the bees. Today we will talk about the honeybees. They are able to understand mathematics. They could add, they could subtract, even they could understand the meaning of zero. They are great and amazing engineers in nature. It's pretty clear that honeybees are tiny mud genius, and they could communicate through dance. They are dancing. The dance is used by the bees to communicate about the distance and the location of the food. If one of the worker bee, let's say, found a beautiful place, lots of beautiful flowers, everywhere carpeted with the flowers. So when she came back to the honeycomb, her dance, called rubble dance, explaining and communicating with the others and giving the exact location of it. Dancing. It's, I mean, unbelievable. How could they do it? We don't know. But today, we will focus on the one thing about them, their honeycomb structure, mathematics of the honeycomb. Today, we will explore the secrets of the honeycomb. When we look closely inside the honeycomb, we find that larvae, babies, and honey are collecting in small hexagonal wax cells that reflect a magnificent engineering design. If you look at this figure, the left side, you could see the honeycomb there. It's a wonderful, it seems something like a man-made thing because it's so precise. Look at this, all of them are hexagons connected to each other. They have 6 walls here. A honeycomb is a mass of hexagonal wax cells built by honeybees in their nest to contain their larvae, babies, and stores of honey and pollen. That's the reason for making the honeycomb. Honeybees start building the comb, that wonderful hexagonal structure, from several points. They are starting from the several points, and the interesting thing about that, they meet at the same point and combine the cells together to make a honeycomb. They will meet somewhere in the middle or somewhere in the top or the bottom without communicating. Maybe they could communicate, we don't know, maybe they are using some other ways to communicate when they are building a honeycomb. But how could they achieve that? We don't know. They work in group. Each group knows the progress of the other group. If something happened to the worker bee, another worker bee will come and she will start from the same point without asking anyone, and she will do her job. If you could try to do the same thing, when I'm explaining this, the mathematics of the bees, I'm inviting 2 students in front of the chalkboard. So I'm giving 2 chalks, or now today we have markers. Okay, please start to draw, one of you from the left-hand side, second one right-hand side, or they need to be close a bit, otherwise it will take a long time. Okay, start drawing the hexagons. And they will be somewhere in the middle, but I am 100% sure they could calculate, they could use any other tools, rulers, protractor, but the result will be like the left one. They won't be a perfect. But if you look at the real honeycomb, look at the right-hand side, they have a measure of it. All of them are standard, equal to each other. And it's impossible to draw perfect hexagons like bees. They are not drawing. We could call them, you know that today 3D printers are very popular all over the world. They are working like a 3D printers, but they have wax. So they are wax printers. They are collecting the pollens, and they are visiting lots of different flowers. They could produce wax, and they are working like a 3D wax printer. And they are printing this honeycomb, wonderful honeycomb. But as a humankind, we are genius. We are the best of the best. We are thinking like that. This is a small insect. But if you try to do the same job, the result will be this. But honeybees can do this easily without any problem. Okay.
You mean that they start from different point
Yeah.
and
They
they
start from
don't coincide?
several points. Yeah. And when they meet, perfect meets. You could not understand, oh, they meet at that point. No, because it will be perfect match.
They don't start from only one point. They start from
Yeah.
several.
Several points.
Incredible. How did they do it?
I don't know. I don't have an idea.
Inspiration.
Satellite navigation.
Satellite navigation.
Yeah, maybe.
Teamwork is the key, I think. Teamwork. Well, we will see.
But you cannot explain with the teamwork also, yes?
Yeah. It's not
In a printer, in a 3D printer, all the structure is given to the computer beforehand.
Yeah, you
Yes,
need
it is
to have a
following a
software.
procedure, yes.
Yeah,
Yes.
you need to have a programmer because we were working with 3D printers in our school. So the students and our IT teacher, they were programming or they were designing, let's say, simple Mac. On it, there is a logo of our school. But it takes a long time to design it. Then they were printing it. But it's the bees, they are printing, but perfect result. Let's take a look at all bit more details.
Maybe all of them must have the same picture in their minds at the beginning.
Yes, somehow. And just remember what I said at the beginning. Their lifespan is at most 6 weeks. 6 weeks. If you want to be an engineer in our world, I think you need at least 4 years, maybe 3 or 4 years.
After being adopted.
Yeah. I'm not counting the childhood and teenager time and so on. But 4 years later, you could be an engineer. Maybe you could design a building or structure like that. But they could live at most 6 weeks. And you have seen first days of their life. It was so quick and wonderful. So let's take a look at all the details. The thickness of the cell walls, as you can see here, which is approximately, it depends on the bees. So their size is different. They are using their size as a ruler because they could enter that cell, which is approximately 0.073 millimeters, plus or minus 0.002 millimeters. So between 75 and 71 all over the world. And each comb is generally 0.95 centimeter from its neighbor. Look at this. If you look at their centers, approximately, no need to be perfect 0.95, but generally like that. It depends on the bee's size.
Centerline distance.
Yeah. There is one more thing. Each cell is exactly like the others, meeting precisely at a 120 degrees. 120, 120, 120. We have the structure. The real question is this: to be or not to be? No. The real question is, why do bees build hexagonal honeycombs? Why? Why is every cell in this honeycomb a hexagon? In mathematics, we have polygons, and we are giving name with respect to their size, number of sides. If we have 3 sides, we are calling it triangle. If we have 4 sides, we are calling that quadrilateral. If we have 5-sided polygon, we will call it pentagon. And if you have 6-sided polygon, we will call it hexagon. So here we have 6-sided polygon, but they are regular polygons. When we say regular in mathematics, you need to understand 2 things. All sides are congruent to each other. All sides are congruent to their length. We are calling that equilateral. This is a mathematical term, equilateral and equiangular. All the interior angles will have the same degree. Here, it's 120 degrees for the hexagon. So the question is this: why is every cell in the honeycomb a hexagon? Do you have an idea?
Ideal use of space.
Wonderful.
It
But
looks beautiful.
bees, after all, they could build honeycombs from rectangles or squares or triangles. But for some reason, bees choose hexagons here. But always hexagons. And all over the world, just imagine there are some bees in Africa, and B is in USA, but they are building the same type of the honeycomb, hexagons. I need to a little bit promote mathematics. I'm so sorry, the science teachers, but mathematics is the queen of all science. Without the knowledge of mathematics,
Okay, let's pass this bit.
Who is the king? Who is the king?
I need to promote my subject.
Good question. Yeah, of course.
Yeah, the things of this world cannot be made known without the knowledge of mathematics. This is Galileo. You know Galileo. Once he said that vast book which stands forever opened before our eyes, I mean the universe, cannot be read until we have learned the language. And it is, be careful about this part, it is written in mathematical language. So if there is something hidden or secrets, called something like the honeycomb, if you want to understand the language of it, you need to know mathematics. Mathematics will help you. And now, today, mathematics will help us to understand. The reason is wax is extremely valuable to the bees. It's really expensive for them. Wax. Remember, they were printing. I'm saying printing, they were building, in fact. They are 3D wax printer working like that. And the wax is extremely valuable for them. It's really expensive. Why? Look at this. Each gram of wax produced, the bee needs to consume 8 grams of honey.
Incredible.
So if you need 1 gram of wax, you need to consume 8 grams of honey. Thousands of honeybees travel thousands of miles, spend hundreds of thousands of hours to find nectar, transform it into a wax, and then fashion the wax to a precise pattern, I mean the hexagonal shape. All those steps make a honeycomb very valuable. So,
Can I ask something here?
Yeah, of course.
For the wax production, they need honey then, but they store the honey in the.
Not only the honey, pollens. I mean,
okay, pollens are enough.
We know the reason, because wax is very valuable for them, expensive. And here we have the ratio of it, 1 to 8. So because of that, least material, maximum storage idea is really important. Increasing efficiency is an important factor for survival. If you want to live longer, you need to use that idea, efficiency. You need to save your energy. So efficiency is the key here. Least material, maximum storage, and maximum strength. It's a little bit related to the engineer part, structural part. So let's take a look at the strength a little bit. Each cell, be careful here, can support 25 times its own weight. Each cell can support 25 times its own weight. A comb of 100 grams of weight can hold in it up to 4 kilograms of honey.
Wow.
100 grams of comb can hold 4 kilograms of honey. Wonderful. I mean, it is one of the strongest structure all over the world. Hexagon structure.
Can I add something here?
How does it do that?
Of course. Yes, Kiran Bey.
Yeah, please. Normally, each cell support 25 times, but if it becomes a comb, it is almost 40 times much more than its weight. If they become a comb together, they hold much more than one cell.
Why?
Because,
again, it's a teamwork.
They support each other.
Yeah, it's teamwork of hexagonal structure.
25 times 100 is 2.5 kilograms, not 4.
Yeah. For one cell.
But if they are together, if there's one cell, it will be like that. But if there are lots of cells, hexagonal cells, and they are stitching regular polygons, now we will see the reason. If you want to tile a plane or cover a plane with cells of equal size and no wasted area. Why hexagons? If you want to tile a plane with cells of equal size, regular polygons, we are calling that regular polygons in mathematics, and no wasted area, we only have 3 regular polygons to choose from. There are 3 possible solutions. if you want to cover a plane without vested area. So it will be triangle, square, or hexagon. And you want to cover the maximum area. All of the teachers, all of the scientists, all of the mathematicians all over the world, they will give you this answer. You need to use a circle because circle gives us the maximum area.
Yeah.
But why they are not choosing circle? Why? Because circle is better than hexagon. If you focus on the area only, you have the same length, the perimeter of a hexagon and circumference of a circle, same. Why? The reason is here.
Space in between left. Yeah.
Yeah. A circle cells are only economical if they stand alone. If you have only one, yeah, the best structure will be a circle. We have lots
It's wasted area. Yeah.
yeah. The problem, first problem is wasted area.
Ali, I think,
Gaps and
Ali, I
holes.
think the bees have answered the question of mankind, how to square the circle, but they have combined the square and the circle.
Yeah.
This might sound very, very basic. That's just like I do a lot of sewing, but in when you do cutting out, you do waste a lot when you do circles.
Yeah.
It's the same, same as
Yeah,
bees.
yeah.
Yeah.
So
Yeah.
the second problem is, there is one more problem. The second problem is, look at the circle. I mean the blue one. No walls can be shared here. If you have a circle, you are not sharing the sides. Because there are 1, 2, 3, 4, 5, 6 points. We are calling them tangent points in mathematics. In other words, you need to draw each circle one by one. There are no common sides, shared sides. So you are wasting material again. That's the second problem. So they are wasteful of both space and material. And the third thing is structure, the strength. Just imagine you have circular shape. How could they be together in a stable form? Just imagine you have balls. You have balls, they have a circular shape, and it's very difficult to make them together. So that's the third problem. We are eliminating the circle. Okay, circle cannot be the answer. What about the other possibilities? We have a mathematical proof of it. There are 3 possible solutions if you want to cover the plane without any gaps and holes. You may use triangle, square, and hexagon. I added here pentagon. You could see the reason why pentagon cannot be the answer, because there are holes and gaps here. You cannot cover the plane without gaps here. That's not possible. Same thing is possible for octagon, 8-sided polygon. That cannot be the answer because there will be holes. You cannot share some of the sides. So let us focus on here 3 things: triangle, square, and hexagon. Why hexagon here? Why it's not a triangle or not a square? The answer is here. Here we have a mathematical calculation. I did it for you. In order to understand this better, I took a 36 centimeter length. Look at this. The perimeter of a triangle is 36. The perimeter of a square is 9 times 4, 36. And the perimeter of a hexagon is 6 times 6, 36. So we have a common length. And we want to cover the largest area. If you have a triangle, it will be equilateral triangle, because regular triangle, it will be equilateral. So the area will be 62.35 if you calculate this. If it is centimeters, centimeter square. If you have a square, it's easy to calculate. 9 times 9, 81. But the area of hexagon will be 98.53. It's the best option, largest possible area, minimum material, and a maximum storage. So we will eliminate triangle and square. There will be only answer. It should be hexagon. The best thing should be the hexagon. I think you don't have any question here. It was a little bit mathematical. And here we have another representation of the why hexagon is better than triangle. Look at this. we have 6 units. The side is 6 units, here 6 units. If you have hexagon, you will cover 6 equal triangles, but here 4. 6 is greater than 4, so you will cover larger area. So hexagon is better than triangle and the square. If you have a constant length, the largest area will be a circle. We did it. And after the circle, hexagon. But the minimum material among them, the best option will be hexagon. So if you combine the area and the material, minimum material, maximum storage, the answer will be hexagon. So that's our mathematical explanation. But somehow bees could know this thousand years ago.
Maybe they tried the other options at the beginning.
Okay, let me
triangle answer.
Another reason is maximum strength. Hexagons are known to be one of the strongest geometric shapes. If you look at the science world, you will see hexagonal structure. It's a part of the physics, engineering, most of the faculties, they are teaching hexagonal structure. And if you look at the nature, snowflakes, they have hexagonal structure as well, snowflakes. And insects, their eyes, they have hexagonal shapes. And there are lots of things. And the bees, here, honeycombs, they are using hexagonal structure. If you look at the gravitational force, because of the gravitational force, if you have a lot and you will put in honey and the baby is in it. So there will be a gravitational force, but here the trick is the load or the force or the stress is distributed equally as a tension. This is a physical term. Maybe Halit Bey will help me to explain this part. This makes maximum use of the strength of the thin wax wall. So you have a gravitational force and you have honey in it. Because of that, you will have an extra gravitational force. And this force or load will distribute it equally, the sides of the hexagon. And it will be more stable. And the structure needs to be physically strong, leak-proof, resistant to attack from predators. So the hexagonal structure is the best option again.
What's leak-proof?
You have honey in it.
Liquid
there won't be any leaking. You won't lose any honey.
Liquid
It will be a very good container for the honey. I mean, it's something like a jar. You are closing it. It's safe there.
Okay.
So
I think there is also another property of it.
Yeah.
So it becomes leak proof also.
Yeah. They are using the shape which is not only the most economical here, but also the strongest one. So that's another reason. Honeycomb is not a 2D structure. It's 3D. It's a 3D structure. And most people are not aware that the 3-dimensional wax cell structure is the most fascinating. The plane geometry, yeah, it was wonderful. If you are a mathematician, you will be amazed. Oh, what a wonderful structure. But if you see the 3D structure, let me show you the 3D structure. As Gürhan Bey said, their bottoms are not flat. It's a 3D structure. You are expected to have the hexagonal bottom. But if you look at the bottom, they are not flat. You will see a convex form of 3 rhombi. Rhombi, it's a polygon. So all sides are same length, equilateral. The bottom of the honeycomb is, we are calling it trihedral. It's a mathematical term, trihedral figure. 3 rhombi there. But why? Why 3 rhombi? I think you have seen the 3D presentation. They could fit together easily, and they could have extra area. I mean, volume. Volume is important. They could enter they are cleaning their cells, and they are storing the honey. Researchers prove that that's the best structure for them. The bottom should be like that. The mathematicians all over the world and thousands of years, they studied the honeycomb structure. 36 BC, before Christ, Marcus Trendus Varro first record of honeycomb conjecture. Honeycomb conjecture means it states that honeycomb is the best way to divide a surface into regions of equal area with the least total perimeter. In other words, it's the best figure for the maximum storage, minimum material. But they were trying to prove it. Mathematicians and the scientists, they were thinking, can we improve this? Can we find a better idea or better solution? Thousands of years, they were studying on it. 36 BC, Marcus Trendus Varro studied on it. 350 AD, Pappus of Alexandria did something. And 1943, there is another mathematician, but 1999, it's really new. He's alive, by the way. Thomas Hales proved complete conjecture. End of the story. That's the best structure. We cannot find a better solution. Honeybees, they had a great job. So that's the perfect one. We can't improve it. We have a proof of it. Look at the proof here. It's called honeycomb conjecture in mathematics. There are 22 pages of it. There are lots of calculations, calculus, integral, derivative calculations. At the end, the result is, yeah, they did a great job. Today, we have a proof of it. Mathematicians, they tried to find 3 rhombi. The angle is really important. It may be a bit higher or lower. Why the rhombi in that form? I mean, the first mathematician, they measured the angle, Maraldi, measured the cells, and he has found 70 degrees, 32 minutes, the one of the angle of a rhombi. The second angle will be around 110, because their sum should be 180 together. So this angle should be, look at the right bottom corner, 70 degree, 32 minutes, the angle. But again, mathematicians always asking, why? Is it the best one? Can you find another one? One of the mathematicians named Koenig found angle. No, they made a mistake. I have found a better solution. The solution was 70 degrees, 34 minutes. Really small. He was thinking mistake. Yeah, they did a great job, bees, but I have a better solution. But unfortunately, or fortunately for us, for the bees, 1743, Maclaurin, another mathematician, found Maraldi was correct. That angle should be 70 degree, 32 minutes. That's the best option. You can't find the better solution, or you can't improve this. And we have a proof of that one also.
What's the meaning of 32 minutes?
32 minutes, when we are measuring the angle, we have a degree.
Each degree is?
Yeah, each degree is 60 minutes, and each
60
minute 60 seconds. So it's a little bit details. I mean, we could say it's 70 degree approximately. But here the difference is 2 minutes. Because of that, I need to write 70, 32 minutes and 70, 34. In fact, Koenig made a mistake. But bees, they didn't make a mistake. They did a great job there. If you have a question, in fact,
actually, there was one more property you didn't mention about it. You said it is leak-free.
Yeah.
Most of the time, these honeycombs are in the vertical position, and they must prevent the honey from the effect of gravity also.
Yeah, 13
Yes,
degrees.
they are, I think, making these cells at an angle. There is an angle for
Yeah,
it.
13 degree. It's 13
13
degree. I forgot to
degree.
tell you that.